welcome back. In this video of Answer With Me session, we'll look into Combined Science Code 5129 Paper 1 of October-November 2010. I will only walk through the physics section. On to question number 1. Here we have the diagram shows part of a Vernier scale. As we can see here, the question is asking what is the correct reading. So first of all, we need to read the Vernier scale. How to read is here, the left side. There's two sides on this Vernier scale. First side is the main scale. On the right side, which I'll label number 2, is Vernier scale. To read the main scale, first of all, we need to identify where the 0 of the Vernier scale, which is this one, lands. So we need to read the number before that. Okay, the starting number of the main scale is 30, and I'll pick the closest number here. Next to 30 is 35. We shall divide these two numbers into 5 intervals, as we can see here. So from 30 till 31, 32, 33, 34, and 35. It is equally distributed. Now again, back to here. As I've mentioned, we have to pick the number before the 0 of the Vernier scale lands. In this case, it is 33.0 millimeter. Okay, the second reading we have to take is from the Vernier scale. How to read Vernier scale is when the two lines of both the main scale and the Vernier scale aligns. That is when we take the reading of the Vernier scale. It states right here the line of both scales align at number 5, but we don't write number 5 here. We write it as 0.5 millimeter. So our working will be first of all, we have our main scale. Our main scale, as we have figured out the number, which is 33.0 millimeter. Second is the Vernier scale, which I'll write as V scale. The Vernier scale is 0.5 millimeter. Align the decimal in one line. Then we have to add both of these number 1, number 2 together to give you the total, which is 33.5 millimeter, which gives us to option B. Next, on to question 2. The gradient of the line on a graph gives the acceleration of a moving object. What are the quantities on the horizontal and vertical axis of this graph? So we can see here there's ABCD with quantity of the horizontal axis and vertical axis. But first, let us see what is the formula of acceleration before we get into the answers. To recap back, the formula of acceleration is the change in velocity divided by the change of time taken. In this case, velocity here, the units are meter per second. Sorry, is meter per second. But in the scalar form, it is speed, which also has the same unit as velocity. Whereas time is just seconds. Okay, on to drawing the graph. Here we have the y-axis and the x-axis. I shall label here. The y-axis, or the vertical axis we call it, and here the x-axis or the horizontal axis. Okay, I don't think I should write it on there. X-axis or horizontal axis. Please do not label like this. This is just for guidance. Oops. So, with the guide of this formula, we can see the similarity in gradient formula. The gradient formula is change of y divided by change of x. So if we correlate to this formula, we can see that the y is, in this case, the y-axis is the velocity or the speed, and the x-axis is the change of time. So let me label here first. The x-axis is the time, and the y-axis is the velocity. Or in this case, in the option given, there's only speed. So let's use speed here. Okay, speed with vertical axis. So in the vertical axis column, we have to find speed. Okay, it's under option D. Whereas in horizontal axis, right here, we have label here as time. We have two options here, time. But the two options that is correlated to the answer is D. The answer which is clearly labeled with this graph is D, with time on the horizontal axis and speed on the vertical axis. Next, moving on to the next question. Question 3. Let me get the box correct size. Okay, question 3. The gravitational field strength is 2 Newton per kilogram on the moon and 10 Newton per kilogram on the Earth. An astronaut returns from the moon to the Earth. What effect does this have on the astronaut's mass and weight? Okay, they're asking mass and weight. Let me underline that. And the key word here is that the astronaut returns from the moon to the Earth back. They're asking what happens to the mass and what happens to the weight of this astronaut. So before we get into anything, let's define what is mass. Mass is the amount of substance in a body or an object, whereas weight, we can depict it with this formula, which is weight is equal to mass times gravity. So gravity here is a factor in weight. Okay, before we get into weight, let's go to mass back again. So since mass is the amount of substance, it means that the astronaut, let's assume it is 50 kg, this astronaut. From the moon to the Earth, astronaut's mass did not change because it is the amount of substance. So both options C and D has the same answer. Whoops, Okay, I should not underline there. Same answer. Oh, now we have to move on to the weight, which we have to pick between whether he has less weight on Earth or more weight on Earth. To figure out, we are given the gravitational field strength of the Moon and the Earth, which is shown here. 2 Newton per kg of the Moon. Let me write it down here. Gravity of Moon is 2 newtons per kilogram, whereas the Earth has 10 Newton per kilogram. So if you were to calculate the weight of the astronaut on the Moon using the formula W equal to mg, which is right here. Let me highlight it here. It would be the mass, as we have assumed it is 50 kg. We'll bring it here. 50 kilogram times the gravity of the Moon. The gravity of the Moon is 2 newtons per kilogram. Kilogram and kilogram cancel each other. Okay, this is getting out of hand. So the weight of the astronaut on the Moon is 100 newtons. Let's calculate the weight of the astronaut on Earth. The mass of the astronaut is 50 kilograms, but the gravity of the Earth is 10 newtons per kilogram. Cancel kilogram together and you multiply 50 by 10 will give you 500 newtons. As you can see, the weight of the astronaut on the Moon significantly increased when he lands on the Earth, from 100 to 500. So the answer is his weight is more on Earth, as shown in the calculation above. So the answer is D. Oops. Alright, that's done. Now on to question 4. Spring question. Hold up. Okay. Question 4. The diagram shows how a spring extends when a weight of 6 Newton is hung on it. On the left hand side, the diagram shows the original length. Alright, let me write it here first. Original length of the spring, which is 10 centimeter. Whereas on the right side, it is extended. Okay, let me write here. Extended length is equal to 12 when it is attached with a weight of 6 Newton of weight. Okay, weight. Alright. Which weight hanging from the spring causes the length to become 15 centimeter? Alright, with this information, they're asking what or which weight will cause the length of this original spring to become 15 centimeter. Okay, first of all, I would like to show you. First of all, we know that spring, the extension, is proportional to the force. So in this case, the extension here, we can calculate the extension by using this formula, which is extension is equal to extended length minus original length. In this case, the extension of this right hand side is we get 12, which is the extended length, deducted with the original length, which is 10 centimeter, which will give you 2 centimeter. Okay, from this proportionality, I shall put here E and F, a tiny table here. So extension here is 2, okay, maybe not 2 centimeter. The force or the weight here is the 6 Newton. Now, they are asking how the length can be stretched to 15 centimeter, which means we need to calculate the extension of this 15 centimeter. Again, using the formula before, extension is equal to extended length deducted with original length, which means extended length in this case is 15 centimeter. We know our original length, it is 10 centimeter. So deduct those two numbers together, they'll give you 5 centimeter of extension of the spring. So we have to write the 5 centimeter of extension of the spring under E. And do we know the weight hanging from the spring that causes the 5 centimeter extension? No. So we'll write there as X. Here's the fun case. We'll do cross multiply between these two columns. With this cross multiply, we'll have 2 centimeter times with X, which will give you 6 Newton multiply with 5 centimeter. Okay, this is getting out of hand. Maybe I should move these numbers somewhere else. Let me move this somewhere else. Alright, that's better. Okay, resuming back the formula and the mathematical equation. X is equal to 6 Newton multiplied with 5 centimeter divided by 2 centimeter. I just moved the 2 centimeter over to the other side, which will result to the second line. Now the third line of the working will be, you will have to cancel the centimeter by centimeter. Just do this quick maths because it's very simple here. 6 divided by 2 is 3, so 3 multiplied by 5 is 15 newtons. So therefore, with the answer here, we have 15 newtons. Okay, let me use red color here and highlight here. The answer is B, 15 newtons. Okay, on to the next question, question 5. We have an electric motor which lifts a weight of 8 Newton through a height of 5 meters in 4 seconds. The question asks, what is the power developed? Alright, first of all, I would like to write down all the important key points here, which is the weight. That's the first thing. Weight is 8 Newton. Height is 5 meters. And the time. Time is 4 seconds. Let me write down in the equation form. Weight is 8 newtons. Height is 5 meters. And time is 4 seconds. The question involves power. We need to recap back what's the formula for power. So power, as we know, is denoted by this equation, which is P equal to work done, and make it shortcut, divided by time taken, or time. Work done, as we know, can be broken down into two factors, which is force times distance. And again, divide by time. Don't forget that. Force in this case is the weight, as both of them share the same unit. And the distance in this case is the height, as both of them share the same unit as well. So we can replace force with weight and distance with height. Again, divided by time. Now we substitute all the number together. 8 newtons times 5 meter divided by 4 seconds. Okay, quick maths again. 8 divided by 4 is 2. So 2 times 5 is 10 watts. So the answer is 10 watts. C. Alright. Next page. Question 6. To protect a polished table, okay, this PDF is moving too much. Okay, to protect a polished table, a cork mat may be put on the table underneath a mark containing hot liquid. So you can see the diagram here. The mark of hot liquid first, then the cork mat, and then the polished table. Why is this effective? Okay, we'll go through one by one here. Option A, cork is a good conductor, but we know that cork is a insulator here. Let me write here. Cork is an insulator. It is not a conductor. It is not a good conductor. So A is out, as this is false. So option B. Next, option B. Cork is a good radiator. Radiator, in a sense, is emitter of radiation. But we know that it is an insulator. So B is out as well. Now C. Cork is a poor conductor. Okay, this can be defined also as insulator, in other words. So this option is plausible because we haven't got to option D. Now option D. Cork is a poor radiator. Okay, the question, going back to the question, the main objective is to protect the polished table. Nothing to do with emitting heat or heat radiation. So to protect the polished table, you need a good insulation, which means C is the correct answer. Alright, on to question 7 now. Question 7. What is the angle of refraction? Refraction. Okay, let me underline that. Refraction. For this ray of light moving from glass, let me circle that, to the air. Let me label it here as well. Glass to the air. So they are asking the angle of refraction. Let me write it here next to the diagram. Angle of refraction. Where the ray of light bent. So here from the glass, which is here, this arrow right here. Okay, let me zoom in. This arrow right here. Oh dear. This arrow, okay, let me erase everything first. This arrow right here is going out from the glass to the air. So the refracted ray is here. next to the D. Let me label with blue. The refracted ray is here. Therefore, this D is the answer. As this is an incoming ray that is going outwards to the air. So the one refracted is the D. Alright. Yeah, this is more of a factual question where whether you can read the diagram or not. That's my honest opinion. Okay, next, on to question 8. Here we have electric current is defined as the rate of flow of charge and is measured in amperes, A, which is the unit. How can the unit of the current can also be written? Alright, here they've given the hint. This current is defined as rate of flow of charge, which means rate meaning per time, flow of charge meaning cube. Or if you memorize the formula, I is equal to Q divided by T, whereas Q, the units is coulomb, and T, the units is seconds. So we just match between all these 4 options, which leads you to D, coulomb by second. Alright, on to the next question. Question 9. 2 resistors are connected in series with a 9-volt supply, as we can see here. And we have 2 resistors, which is 1.5 ohms and 3 ohms. They are connected in series. So let me write here, series. The question is asking what is the current flowing in this circuit. Okay, we have current. Let me label that with the symbol I. We have resistors, and we have the 9-volt supply, which is V. So V is equal to 9 volts. R, there's 2, which is in series, and we know in series we can use this formula. R total is equal to R1 plus R2, which gives you 1.5 ohms plus 3 ohms. So you add those 2 numbers together, that'll give you 4.5 ohms for total of resistance. And last but not least, we don't know what's I. We can then use the formula V equal to IR to figure out what is the I. So make I as a subject and you get V divided by R, which is also, the V is 9 in this case, and the R, we're going to use the total resistance now, which is 4.5 ohms. 9 divided by 4.5 gives you 2.0 amps, or you can just use your calculator on this case, and the answer is A, which is 2 amps right here. Okay, moving on to the next question, which is question 10. Whoops, okay, it went up. Question 10. A circuit consists of a battery and 4 resistors. The 4 resistors here is arranged in the sense that there's 2 resistors in parallel in each 2 parallel mini circuit. I'll call it mini circuit here. Okay, moving on to the question. The current in the 3 resistor is shown. We can see here. So they are asking what is the current in X, which is in this branch. Alright, now we know that the current in series is sum of each branch, which that's my definition of the current in, oh wait, hold on, it's not current in series. Alright, terribly sorry, it's not current in series, current in parallel. Oh dear. Current in parallel is the sum of each branch, or it is different in each branch, or it can be shown as a equation, which is I total equal to I1 plus I2, or if there's more branch, it will be I3 and I4 and so on. So in this case, I would like to see it this way. This is the circuit, this is the branch that was from the battery. Now this branch will be split into two branches, as you can see here, to 2 amps and 3 amps. So when these 2 amps and 3 amps went back to this point here, this wire here will have 2 amps plus 3 amps added together, which will give you 5 amps. Now when it reached this branch, it will split up again. We know that in this branch it is 3.5 amps. Now do we know this case? Yes, because we know that the main branch is 5 amps. We know one of the branches 3.5 amps, and we don't know X. So make X as a subject, that'll give you 1.5 amps. And we can see here the answer is A, 1.5 amps. Right, moving on to the next question. Question 11. A 2 kilowatt appliance is to be connected to the 240 volts main supply. Which fuse should be fitted in the plug? Oh dear. Alright, the key word here is 2 kilowatt, which is in the form of power, and 240 volts, which is in the form of V. They're asking fuse. Fuse always relates to current or I. Now we can use the formula P equal to IV. We know P is 2 kilowatts. 2 kilowatts we have to convert to watts, which will give you 2000 watts. We don't know I, so just let it be there. We have 2000 watts is equal to I. We don't know I, so just let I be I. We don't know the current, so just let I be the symbol. Then we know V. V is 240 volts. Make I as the subject here, which will give you I is equal to 2000 watts divided by 240 volts. With calculator, you'll be able to obtain 8.33 and so on, which will never ends. So in the fusing rate, in the fuse rating, the fuse must be always greater than the current, which means among these 4 options, only option D is greater than 8.33. So we'll have to choose option D. Alright, next moving on to question 12. What is the nucleon number of a nuclide? Okay, this is a factual question where nucleon is another term for mass. of a nuclei. We know that mass is actually the sum of neutron and proton. So in this question, it is automatically option C, as the answer is right here. The total number of neutrons and protons. On to the last question. Question 13. A radioactive material gives a count rate of 8,000 counts per minute. After 20 days, it gives a count rate of 500 counts per minute. What is the half-life of the material? Alright, this kind of question, I'll approach it differently. First, I'll write 8,000 counts per minute. You don't have to write that down, just need the number here. And then on the far right corner or right side, we'll write 500, the number 500. So we know that a radioactive, when it undergo a half-life, the count will be divided by 2, or will be halved in a sense. So this 8,000, when it undergo a half-life, the 8,000 will be reduced to 4,000. And then when it undergo another round of half-life, it'll go to 2,000 and so on until it reaches this, the number 500. So there is overall a total of 4 half-life in the span of, wait, hold on, let me try my best to connect this line. In the span of 20 days. Therefore, we have 20 days to be divided by 4 half-life. The half-life here I represent it as lambda. So 20 divided by 4 is 5 days per half-life, which is the option B. And there you have it. So that's all for today. Thank you for listening.